A pleasant day, grade 9. Today we are going to discuss Module 21 of Physics 9. Before we proceed, here are today's instructional objectives. At the end of the lesson, with at least 75% proficiency, you should be able to first, define projectile motion. Second, compute for the x and y components of the projectile. Third, explain the importance of proper angle and velocity of the projectile in sports. Before we progress with the discussion, here is the initial question. Have you ever played any sports before? Did you know that physics is the heart of every sports and games? You played basketball, game of dart, figure skating, billiard, and soccer. But this is the question, how physics contribute to these games and also sports? Anyway, what is physics and why should we care? Physics is a branch of science which deals with the concept of force, motion, energy, and also work. It gives us scientific literacy and asks questions which starts with how and why in order to predict how the universe works. Physics is also a part of our daily life, especially today that we are living in a technological society. Lastly, it gives us awareness and safety precautionary measure in order to avoid accident and reduce casualties. In your previous year level, we discussed the Newton's law of motion, which deals with motion in one dimension. A two-dimensional motion is under what we call projectile motion. One of the common examples of a projectile motion is when you throw a basketball in a ring. What is a projectile motion? Projectile motion is any object thrown at an angle other than 90 degrees with the horizontal, meaning to say, any object that is moving horizontally as well as freely falling at the same time. The pathway of the projectile is known as the trajectory. Now, projectile motion has two components, and these are the horizontal component and also the vertical component. We will use the variable x to express the horizontal component and variable y to express the vertical component. The vertical and also horizontal components of a projectile are independent to each other. Based on the illustration that I provide, take note that the upward and the downward arrow will represent the vertical velocity of the object. On the other hand, the sideward arrow, the arrow pointing to the right, will represent the horizontal velocity of the object. Alright, basing in our illustration, we can conclude that in a projectile motion, the horizontal velocity of the object will remain the same. On the other hand, the vertical velocity of the object as it goes upward decreases. The peak or the maximum height indicate that the velocity, the vertical velocity of the object is equivalent to 0. Now, when the object starts to drop off after it reaches the maximum height, the vertical velocity will then increase. One of the major factors which affect the vertical velocity of the object is the gravitational pull. Our gravitational pull is constant, which is negative 9.8 meter per second squared. The negative sign indicates that the gravity is pulling the object downward. As we said, the horizontal and vertical component are independent to each other, meaning to say we can express them using different equations. So we can break down the velocity, displacement, as well as the acceleration. Now, the acceleration of the horizontal component, we have horizontal acceleration is equal to 0, since the horizontal velocity of the projectile is constant. On the other hand, the vertical acceleration of the projectile is equal to the gravitational pull, because one of the major factors which affect the projectile is the gravity of the Earth. Next, we have the velocity. Initial horizontal velocity is equal to the initial velocity cosine theta. On the other hand, the instantaneous horizontal velocity is equal to the initial horizontal velocity. So when we say instantaneous velocity, we are referring to the instant velocity of an object at a certain point in a given time. Let's go now with the vertical component. Initial vertical velocity is equal to initial velocity sine theta. For the instantaneous vertical velocity, we have the formula Vy is equal to initial vertical velocity plus the gravitational pull times time. Next, we have the displacement. What is displacement? Displacement refers to the distance from the initial point to the final point. How far did the object reach? We have the formula for the horizontal displacement. Horizontal displacement is equal to instantaneous horizontal velocity times time. For the vertical component, we have vertical displacement is equal to initial vertical velocity times time plus 1/2 times the gravitational pull times time squared. As an alternative formula, we have vertical displacement is equal to the instantaneous vertical velocity squared minus the initial vertical velocity squared divided by 2 times the gravitational pull. Okay, let's apply the following equation to a given problem. We have the statement of the problem. A marble rolls off the edge of a tabletop with an initial speed of 15 meters per second. In 0.50 seconds, how far does it travel horizontally and vertically? Okay, the first thing that we need to do is to visualize the context. We have a marble which dropped off vertically, horizontally. Now we need to find the distance from the initial point until it reached the landing point. We are talking about the displacement. Now, after visualizing the context, we need to find the given. In order to find the given, you must read the problem carefully. We have the initial speed, 15 meters per second, and the time, which is 0.50 seconds. You can also write the value of the gravitational pull, which is negative 9.8 meters per second squared. Now, we are looking for the horizontal and vertical displacement of the marble. Next is to identify the following formula that we are going to use. Of course, we have two components, horizontal and vertical components. Therefore, the formula will be different from each other. So, for the horizontal component, we are going to use the formula Vox is equal to initial velocity Cause take note that the initial horizontal velocity is equal to the instantaneous horizontal velocity. We also have the formula for the horizontal displacement, in which dx is equal to instantaneous horizontal velocity times time. Next are the formula for the y component. We have the initial vertical velocity, which is equal to the initial velocity sine theta. To find the vertical displacement, we have the formula dy is equal to 1/2 times the gravitational pull times time squared. Now let's make use of the following formula. Let's find the initial horizontal velocity. Now, based on the given, what is the value of the initial velocity or the VO? We have 15 meter per second. How about the angle? The value of the angle will be 0 since the marble is dropped off from the maximum height. 15 meter per second cosine theta is equal to, the product will be 15 meter per second. Do not forget to box out your final answer. Take note that the instantaneous horizontal velocity is equal to the initial horizontal velocity. So if we have 15 meter per second as our initial horizontal velocity, then the instantaneous horizontal velocity will also be 15 meter per second. Now, let's find the horizontal displacement. We have dx is equal to instantaneous horizontal velocity times time. Now, what is the value of our vx? We have 15 meter per second. How about the time? Okay, refer to the given, we have 0.50 second. Let's substitute the given. We have 15 meter per second times 0.50 second. So, we need to cancel out the unit of the time, which is second. Now, 15 meter times 0.50, we have the product 7.5 meter. Okay, let's box out our final answer. Take note that the final answer should be 1 decimal place only. Now, let's look for the vertical components. Let's start finding the initial vertical velocity, wherein VOY is equal to initial velocity sine theta. Now, what is the value of our initial velocity? Okay, we have 15 meter per second. How about the angle? The angle will be 0. 15 meter per second sine 0. We have the product 0. Now, let's look for the vertical displacement using this formula. We have dy is equal to 1/2 times the gravitational pull times time squared. So we have 1/2 times negative 9.8 meter per second squared times 0.50 second squared. Now, we have to deal first with the exponent. We have to distribute the exponent inside the parentheses to 0.50 and to the unit s. What will be the result? We have 0.25 second squared. Next, we have to multiply negative 9.8 meter per second squared to 0.25 second squared. But before that, of course, we need to cancel out the unit of the time, which is second squared. The remaining unit will be meter, since we are looking for that displacement. So we have 1/2 times negative 9.8 meter times 0.25. So We have to deal first with negative 9.8 meter and 0.25. The product will be negative 2.45 meter. Negative 2.45 meter. Divided by 2, the quotient will be negative 1.225 meter. So we need to simplify the answer into one decimal place only. So we will get negative 1.2 meter. Then backs out the answer. We have example number 2. We have the same statement of the problem. We change some of the given. We have a marble rolls off from the edge of a tabletop with an initial speed of 16 meter per second. In 0.20 second, how far does it travel horizontally as well as vertically? Let's visualize the context. Let's identify the given based on the stem of the problem. The initial speed of the marble is 16 meter per second and the given time is 0.20 second. We are going to use the same formula for x component and y component based on our first example. Let's look for the horizontal component. We have the formula for the initial horizontal velocity. Vox is equal to initial velocity cosine theta. For this example, the initial velocity is 16 meter per second. Again, the angle is equal to 0. Let's substitute the given. We have 16 meter per second cosine 0. We have the product 16 meter per second. Now, take note that instantaneous horizontal velocity is equal to initial horizontal velocity. So, if we have 16 meter per second as our initial horizontal velocity, then the instantaneous horizontal velocity will also be 16 meter per second. For the displacement, we have the horizontal displacement is equal to the instantaneous horizontal velocity times time. The value of Vx is equal to 16 meter per second. And the given time is 0.20 second. Substitute the given. We have 16 meter per second times 0.20 second. Cancel out the unit of the time. We have second. We have the product 3.2 meter. Now let's proceed with the vertical component. We have the formula for the initial vertical velocity. Voy is equal to initial velocity sine theta. The initial velocity is 16 meter per second. The angle is 0. So we have 16 meter per second sine 0. We have 0. Now let's look for the vertical displacement. The formula is dy is equal to 1/2 times the gravitational pull times time squared. Let's substitute the given. We have the value of the gravitational pull, which is negative 9.8 meter per second squared. We also have the value of the time, the given time, 0.20 seconds squared. Now, distribute the exponent inside the parentheses. We have 0.20 and second. 0.20 squared is equal to 0.04. Then distribute the exponent to the unit of the time, which is second. We have s squared. Now, negative 9.8 meter per second squared times 0.04 second squared. We have to cancel out the unit of the time, s squared. The remaining unit will be metered. Since we are looking for the vertical displacement, negative 9.8 meter times 0.04, we have the product, negative 0.392 meter. Divided by 2, we have the quotient, negative 0.196. To simplify the answer, we have negative 0.2 meter. What if here is the case? We are given with an angle. Here is the statement of the problem. A soccer ball was kicked at 35 degrees off the horizontal with an initial speed of 20 meters per second. Find the initial horizontal velocity, initial vertical velocity, time the object reached the maximum height, time of flight, maximum height attained by the object, and the range. Analyze the problem. We have the initial velocity, which is 20 meters per second. The given angle is 35 degrees. So let's write the value of the gravitational pull, which is negative 9.8 meters per second squared. We are looking for the following items. We have initial horizontal velocity, initial vertical velocity, time the object reached the maximum height, time of flight, maximum height attained by the object, and also the range. Let's visualize the context using this illustration. So we have the given initial velocity, which is equal to 20 meters per second. The angle 35 degrees. The maximum height, we are looking for the maximum height attained by the object, the time in which the object reached the maximum height, the time of flight, which is related to time symmetry. It pertains to the time spent by the ball to make a complete rotation from this point to this landing point. We are also looking for the range, this point to this point. Now we are going to make use of the following formula. Let's look for the initial horizontal velocity and initial vertical velocity. For the initial horizontal velocity, we have the formula Vox is equal to initial velocity cosine theta. The value of initial velocity is 20 meters per second based in our given. We also have the value of the angle, which is 35 degrees. Now let's substitute the given. We have 20 meters per second cosine 35 degrees. The product will be 16.4 meters per second. Take note that instantaneous horizontal velocity is equal to initial horizontal velocity. Therefore, if we have 16.4 meters per second as our initial horizontal velocity, then the value of the instantaneous horizontal velocity is also equal to 16.4 meters per second. Moving forward, we have the initial vertical velocity. The formula to find the VOY is VOY equal to initial velocity sine theta. The value of the initial velocity is 20 meters per second. The value of the angle is 35 degrees. Let's substitute the given. We have 20 meters per second sine 35 degrees. The product is 11.5 meters per second. Moving forward, let's look for the time in which the object reached the maximum height in a trajectory. We will be using the formula for the instantaneous vertical velocity, in which Vy is equal to initial vertical velocity plus the gravitational pull times time. the value of the Vy is equal to 0. Initial vertical velocity is equal to 11.5 meter per second. The gravitational pull is constant and therefore equal to negative 9.8 meter per second squared. The first thing that we need to do is to substitute the given. Now, transpose 11.5 meter per second to the other side of the equation. As we transpose 11.5 meter per second, the sign will be changed into negative. So we have negative 11.5 meter per second. Now, divide both sides by negative 9.8 meter per second squared. Let's cancel out negative 9.8 meter per second squared in this side. For the other side of the equation, let's cancel out the units for the meter in the numerator and also the denominator. Now cancel out the unit for the time in the numerator and the squared in the denominator. We have the remaining unit, second. Negative 11.5 divided by negative 9.8 second. We have the quotient, 1.2 second. Proceeding, let's look for the time of flight. In order to find the time of flight, we need to multiply the time into 2. 2 times 1.2 second, we have the product 2.4 seconds. Moving forward, let's look for the maximum height attained by the object. We have the formula dy max is equal to instantaneous vertical velocity squared minus initial vertical velocity squared divided by 2 times the gravitational pull. The value of the Vy is equal to 0. On the other hand, the value of the initial vertical velocity is equal to 11.5 meter per second squared. The first thing that we need to do is deal with the exponent. Distribute the exponent to 11.5 and to the unit meter and second. Now we have negative 132.25 meters squared second squared. The sign will be negative. The sign will be negative since the negative sign is located outside the parentheses. Now, let's cancel up the unit. Cancel the unit for the time second squared. Cancel the squared in the numerator and meter in the denominator. We have negative 132.25 meter divided by negative 19.6. Negative divided by negative, we have positive. 132.25 meter divided by 19.6. We have the quotient, 6.7 meter. Now, let's deal with the range. The formula for the range is Vox times the time of flight. The value of the initial horizontal velocity is 16.4 meter per second. For the time of flight, we have 2.4 seconds. We need to cancel out the unit for the time. We have second. Now, 16.4 meter times 2.4. We have the product, 39.4 meter.